Hello everybody and welcome to our new Lifehack. This is Patrick from NUMECA Ingenieurbüro, and today I would like to talk about ZR effects in Fidelity Autogrid, or meridional effects. Basically here we are talking about simple axisymmetric geometries that can be meshed by extruding a 2D blocking. Maybe let me show you this on our demo case for today. So today we will be working on a two-stage centrifugal compressor, and basically what we would like to do is we would like to consider the back phase leakage path of the first stage, and later in the extended version, I will come to that in a minute, I would like to also consider the shroud leakage path of the second stage, because the second stage is basically a shrouded impeller, as you can see right here. And these simple this simple geometry basically can be meshed with what we call a ZR effect, which is basically just a 2D blocking extruded in the azimuthal direction. So that's our topic for today. There will be a short version where I basically show the very minimum that you will have to do in Fidelity Autogrid in order to create a structured mesh for this setup right here. And there will be an extended version where we will be going a little more into details. Specifically, we will create a matching connection between the ZR effect or this back phase geometry with the main channel. And we will also be talking about this right here. What we see here is basically a ZR effect with two connections. So that's basically the program for today, and I suggest we get started. So before we start, allow me to show you the final objective for today, or a small preview. The idea is to create a structured mesh of both stages, including the return channel, and of course considering these leakage paths, in this case, which are connected with a matching connection to both impellers. Here we see the first stage, and in the extended version of this life hack, we will consider the shroud leakage path for the shrouded impeller. And we can see this right here in a ZR view. So this is basically what we are going to create. Okay, so let's get started. Let me just switch to this new template right here. What I did so far is I imported the Geom Turbo from Accent, and we will get started by enhancing this view right here. And in this first part of the life hack, we will only consider the first ZR effect, which has one connection to the channel, and that is the first so that is basically the first thing you have to consider. Do you have one or two connections to the channel? So this first ZR effect will have one connection because it is only connected at one location to the main channel. The second ZR effect, on the other hand, will have two connections. So that is something you have to consider already at the beginning, but we'll get to that in a minute. The first thing you will have to do is I will click here on the mesh assembly and add ZR effect with one channel connection in order to get started with this first setup right here. Then a new this new button here will pop up, ZR effect 1. I will just call this back phase of impeller 1. And the first thing I have to do is I have to define the domains for these for this ZR effect. However, this requires a closed curve or a closed domain. And as you can see, this domain right here is still open. And if I would like, or if I would try to define this as a domain, Fidelity will give me an error. So the first thing I have to do is I will create a curve which closes or better connects these two curves. And you can do that by simply expanding your assembly right here. Click on channel and say create meridional curve. Then I zoom in a little, wait until these points pop to the curve, and right click to exit the curve generation mode. And now this curve is basically closed, and I can select this first ZR effect, go to boundary definition, click on the curve. As you can see now, it recognizes this is one curve belonging together. I can click on it, and now this symbol, which was red a second ago, is now green, meaning that the boundary definition was successful. Next, I would like to already assign boundary conditions. Specifically, I would like to tell Fidelity which part of this ZR effect will be, for instance, rotating, or which part of this ZR effect might be an outlet or also an inlet boundary condition. However, in order to do that, I will have to divide this curve first, because right now it's basically one boundary, it's one curve. So I will have to split it. And to do that, I simply go to outer boundary here in my case, and click on this right here, on this option saying show control points. And then all the points that define these curves will pop up. And if I zoom in a little, I can click on this point and say right click, boundary division. I will do the same up here. And now, as you can see, I can select this curve individually of the rest, or this curve right here. And I can also now assign a boundary condition here in the property window. So for instance, I would like this curve right here to be a rotating wall. So I will keep this boundary condition at wall. I will select rotating. This right here will be a stationary wall, and I would like this to be an outlet. And after the meshing process and after we created the simulation, these walls will automatically have these boundary conditions. So you can also change this later, but it's easier if you do it directly here. Okay, and that's pretty much all there is to do here in the geometry context. So I will just go to domain, and as per default, if we work with turbo assemblies in the family tree, all the simulation domains will automatically be created, including the domain for the ZR effect. Also, the full non-matching boundary condition or the full non-matching connection will automatically be created. So there is pretty much nothing for us left to do here. So I will just close this. And we come to the meshing process. I will keep the meshing of the remaining turbomachine as simple as possible. All I'm going to do is I will apply a few default settings here for the wizard. So now I'm basically applying the wizard to the first and the last stage. Now let's consider the return channel. So as you can see, there's really not that much to do. And I get a preview down here of my blade to blade mesh. Now regarding the ZR effect. As you can see here, we have this new domain. I will focus on the ZR view right here. That is something you should do when you start with the blocking, because you might not have all options available if you are in the 3D view. So as soon as you start blocking with this ZR effect, I recommend switching to the ZR view. You can click here on this domain representing the ZR effect, and now you can apply a few default settings. For instance, I will add a number of optimization steps. You can directly activate the automatic blocking, which will lay in a default blocking, and you will also get a preview of your grid. So as you can see, this blocking process was successful. Now I will just apply a few more settings here. There's actually not much that we'll have to do. I will just decrease this value right here, and then you can get a preview of the default mesh and run the optimizer, and then as you can see, you get a pretty good start for your grid. Yeah, we still have, it seems we have some issues here with the clustering. I will not consider that for now, for the sake of shortness of this video. I think I will just keep it at that. And what we will now get is a grid which will have a full non-matching connection right here. And in the second part of this video, we will try to get a matching connection. So let's just try this. I will save this setup right here and create the 3D grid. I will pause the video for a second here. Okay, so I think this was successful. Let's take a look. Yeah, actually I think we're doing pretty good. So the grid quality, I would say, is acceptable. Let me just switch to the 3D view and let's take a look what actually happened here. Yeah. So we have our 3D grid from our centrifugal compressor and from the return channel, and as you can see back here, we also have the 3D grid for our ZR effect. And as I mentioned, this will not be a matching connection. So we will be creating a full non-matching connection right here. So there will be some interpolation taking place. So on the other hand, if you remember, let's go back to our, let me just check, to our template. If I zoom in to the trailing edge of the impeller here, as you can see here, the connection is matching, which we'll be doing, or I will be showing this in the extended part of this video. But as you can see, this is not the case here. So Fine Turbo, or better Fidelity Turbo, the turbo solver, or whichever solver you will be using in Fidelity, will have to do some interpolation here, but it will still run. Okay, so that was pretty much all I wanted to show for this very brief version of this video. For those of you who will not be who will not be looking the remaining part of the video, please give us feedback. Let us know if you have additional questions. I will continue here and conduct the grid generation for a matching connection and for the second stage. All right, see you then.